Okay, so we're looking at slope and change in slope. So how does it affect the graph if we change the slope or rate of change? And we're also going to look at direct versus partial variation again. So in this first example, we're talking about the distance traveled by a car. We have the distance on the y-axis and time on the x-axis. And we want to figure out how fast it's traveling. So if we look at the line tells us how fast it's going because we're figuring out the distance and the time, kilometers per hour. If I look 1 hour, how far do we travel? 75 kilometers. So how fast is the car traveling? If we go over 1 hour, that means we went up 75 kilometers. So that's 75 kilometers per hour. And the line's not changing, so every hour it's going up 75. It's changing by 75 kilometers. So every hour is 75 kilometers. This is the car's speed or rate of change or slope. Okay, so I'll say rate of change or slope interchangeably. So the next question say what happens if the speed is increased or what happens if it is decreased? Well, if it's increased, instead of going 75 kilometers for every hour, let's say we go 150 kilometers an hour. This person is really speeding. Use a different color here. So for every hour, we go up 150 kilometers. Or if we go slower, let's say we go 1 box up, so half of 75, that'd be what, 37.5? So over 2 boxes, up 1. So over 1 hour, up 1 box. The graph is going to look like this. So this is the slower line. This would be faster. So what happens to our graph? If we compare it to the red one, when we increased the speed, the line got steeper. And when we decrease the speed, the line was less steep. Okay, so the steepness of the line changes depending on what the rate of change is, or the slope. So let's look at Chris here. Chris runs each day as part of his daily exercise, and we have a graph here of what he did. So again, this is distance and time. So you might be wondering why it comes back down. Well, this is distance. Let's say it's distance away from his house. So his house is at 0. He goes away from his house and then comes back home. Okay, so his house is everywhere along this line because that would be distance of 0. But it keeps going this way because time increases. So as time goes on, he's going away from his house and then comes back to his house. And before we actually calculate it, I want to look over here. We have a formula and a diagram. Slope is equal to rise over run. Rise divided by run. Remember that line means division. So when we look at a line, if we look at 2 points on that line, the vertical distance between those 2 points is called the rise. The horizontal distance is called the run. So we just count over 1, 2, 3, 4, 5, 6. Count up 1, 2, 3, 4, whatever it is, and then we divide those numbers to get our slope. So for instance, the slope from A to B. Our run, we go this way, is 5 minutes. So I'm assuming that means it's 200. So our rise would be 200 because we went up 1 box. So rise is equal to 200 because that's what the scale is. Our run would be 5 minutes. So our slope would be 200 over 5, our rise over run. Okay, so then if that wasn't, if you couldn't divide that, you could reduce the fraction. You could also put the decimal, it doesn't really matter, but 200 divided by 5 is 40, so we'll say that. And we had, the rise was in meters and the run was in minutes, so that's 40 meters per minute. So now if we do the same thing for B to C, we're looking from here, this point B to that point C. So we draw a triangle like this, and I look across. Well, the run is 1, 2, 3, 4, 5. 5 minutes again. And we're going up 1, 2, 3, 4 boxes, but we have to remember that each box is 200 meters. So for those 4 boxes, since they're all 200, that would be 800 meters. So our rise is 800. The run is 5 minutes. So our slope is 800 over 5. Again, you want to divide that to get 160 meters per minute. And then you continue, so from C to D, our rise would be 400. Again, the run is 5. So our slope of rate of change would be 400 divided by 5, which is going to be 80 meters per minute. Now from D to E, it goes straight across. So I have a run, but I don't have a rise. There's no up or down. So my rise would be 0. So my run is still 5. My slope would be 0 over 5, or 0 meters per minute. So you've probably thought about it now. He's staying at a distance of whatever that is, 2, 4, 6, 8, 10, 12, 1,400 meters away, and not going closer to his house or further away from his house. He's stopped. He's not moving anywhere. He's staying in that one spot. So he's resting, he's catching his breath. So it's a horizontal line, which means the slope is 0. And then finally, E to F. So our run is 5. Our rise would be 1, 2, 3, 4, 5, 6, 7. Get it? I did that already. 7 times 200 would be 1,400. Run is 5. So the slope would be 1,400 divided by 5. And that would be, I don't know, 1,400, 280. Now this may not be realistic for a run. I don't actually know, but that's the speed that he is running during those different times. So that's how we calculate the slope, rise over run. Okay, so what was Chris's fastest running time? 280 meters per minute. What was his slowest running time? Now, if you said D to E, well, this was E to F. If you said D to E, where he stopped, I would say that's true too, but he's not running, right? He's stopped. So what is his slowest running time? 40 meters per minute. That was A to B. But again, if you put 0, I get it. That's the lowest speed. Okay, so now again we're looking at direct variation, partial variation, and then also looking at equations of it and descriptions, and then how it would change later. So this first graph that we have here on the left, it does not start at 0, it starts up here. There's an initial value, which means it is partial variation. Which means that the graph on the right, because it does start at 0, would be direct variation. So description. Now we're not going to actually create our own description. We have it at the bottom here. We have to match it. Our first option is creature comforts. Dog kennel costs $28 per day. Or Raina rents a moped while on vacation. She's charged an initial fee of $35 plus $2 for each liter of fuel consumed. So since there's an initial fee here, I know that that would be our partial variation. If there's an initial value, initial fee, anything like that, that's going to be partial variation. So I'm going to say, I'm not going to write out the whole thing. This is Raina's moped. So the other one would have to be the Creature Comforts dog kennel, because it's $28 per day. If you don't go, if it's 0 days, your dog does not go to this kennel, then it costs you $0. So that would have to be direct variation. So now we want an equation. Let's look at Creature Comforts, the dog kennel. That's the easier one. So if it's $28 per day, the cost would be $28 times the number of days. We don't know the number of days, but that's the point. It could be 1, it could be 5, it could be 15 days. But it's $28 times the number of days. For Raina's moped, she's charged an initial fee of $35 plus $2 for each liter of fuel. So the cost would be $2 for every liter of fuel plus the $35 that she started with, the initial fee. So I'm not multiplying that by anything because it's just a one-time fee. It doesn't matter how many liters of fuel she uses or anything. That's just the one-time fee of $35. And then we add $2 for every liter of fuel. So that's direct versus partial variation. But now let's look at what would happen if things changed. So suppose the daily cost of the dog kennel increases to $30. It used to be 28, now it's 30. So how does the graph change? We saw before in the car that if the speed increased, the graph got steeper. So in this case, if the daily fee is higher, the graph gets steeper, or the line gets steeper. So we're going to sketch it up there. Quickly, come up here. The line will get steeper. So how steeper, or how much steeper, I don't know, but something like that. And what would the new equation look like? Well, if it was C equals 28n, since they're now charging $30, it would be 30n. So how does the equation change? The rate of change, or the slope, is now 30. But now let's look at the moped. So the initial fee has been reduced to 28, but the fuel is increased to $3 per liter. So lower initial fee, higher per liter of gas. So how does the graph change? Well, our initial value is lower. Forget you guys don't know cursive. Initial value is lower, and the line is steeper. So let's go back up. It's going to be cheaper at first to rent, but then it's going to cost more per liter to drive that moped. Now we're just sketching it. We don't have numbers or anything. It's just getting a sketch of what it might look like. Okay, so what happened? The value was lower. Initial value was lower, so we started lower on the y-axis, and the line was steeper. Now, how would the equation change? Well, everything changed. The initial value is down to 28. So the initial and the slope, or rate of change, is 3. So what would the new equation be? 3n plus 28, whereas before it was 2n, because it was $2 per liter, plus 35. Okay, so we looked at direct variation, partial variation, and how an equation would change, how the graph would change if we change the slope in the situation. So I have 4 questions here for you to practice. Please look at them and then look at the assignment for this week.